Hello friends, in today's question, a particle of mass m is projected with a velocity v making an angle of 45 degrees with the horizontal. The magnitude of the angular momentum of the projectile about the point of projection when the particle is at its maximum height h is. So these are four options. So it is given that particle is being projected. So let's draw the figure. So it is projected with the velocity of v making an angle of 45 degree, and we are supposed to find out angular momentum at maximum height. So let us suppose this is point P, and which represents the maximum height given as h. So at the point of maximum height, we already know that the velocity which is only there is the horizontal velocity, which will be given as v cos of 45, and this velocity vector can be further divided into two components. This will be v cos of 45, and along the y-axis we can write this as v sine of 45. So we can use a basic kinematic equation to find out the relationship between the height h and the velocity of projection, that is v. So as the height, this is our coordinate system, this is our x-axis and this is on the y-axis. So we take along in y direction, you can use the equation of kinematics, which says that v square is equal to u square plus 2as. So it is in y direction, so let us suppose this is y as well as y, and we can say v of y will be equal to v sine of 45, sorry, u of y, initial velocity, and final velocity y direction is 0, and we can say acceleration of in y direction will be given as minus of g. This is u. So we substitute it here, we get 0 is equal to v sine of 45 whole square minus, and s is our height h, this will be minus 2gh, or we can say v square sine of 45 is 1 by square root of 2, and this will be 2gh. So we can say that our h will be equal to v square divided by 4g. This is a relationship at point P between the height and the velocity of projection. And we already know that at point P, the only component that is available, velocity component, is horizontal. Therefore, the momentum that will be present at point P will be only dependent upon the horizontal component. Okay. So you can see momentum at the highest point P will be only due to horizontal velocity component as vertical velocity component is 0. Therefore, we can write it as momentum at point P. Let us suppose that is given as P, which will be equal to mv cos of 45, and we are supposed to find out the angular momentum. So you can say, therefore, angular momentum will be equal to linear momentum. Let me write it linear. Will be linear momentum into perpendicular distance of linear momentum from the axis. Therefore, we can say that L is equal to P multiplied by H. Now we simply substitute the values. We get L is equal to P into H, and value of P is mv cos of 45, and H is v square divided by 4g. So you can say that L is our mv cube, and cos of 45 is square root of 2. So this will be 4 square root of 2 multiplied by g. So this is the angular momentum at the highest point P. This is the angular momentum at the highest point P for the projectile. So if we check the option mv cube upon 4g, we have mv cube 4 root g. So option number B is the correct option. You can say option B is correct. So this completes the question. Thank you.